ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. Welcome to session 2 of Unit 3 Assembly Modeling, which covers the course outcome creating 3D parts of plumber block of the course Mechanical Computer Aided Drafting for 3rd semester Mechanical Engineering. So today in this session we will learn how to create the parts of plumber block. So this is the detailed parts of plumber block, in which we have 8 number of parts. So the first part is called as body, second is cap, third is bearing bottom half, fourth is bearing top half, fifth is bolt M10, sixth is nut M10, seventh lock nut M10, eighth is shaft. So first we will create the body using solid edge. So to create body, so we will only create the right half section of the body using solid edge. So to create that, we'll start from this point and draw a line like this. Outer portion of the body will be drawn. Of dimension 168 divided by 2 is 84. So we will go to solid part, solid edge, create solid part, select command protrusion and select front plane, select line command, start from the center onto the right side like this and onto the top. Close this. Now give the dimensions, smart dimension. So this length will be 84 mm, that is 168 by 2, and from here to here it is 14 mm, and from this point, end of this point to end of this line, it is 4 mm, and from here to here it is 43 mm, and then 22 and 19. This is 43 mm. From here to here it is 22 mm. From here to here it is 19 mm. This length is 12 mm. This is 3 mm. From here to here it is 55 mm. So after creating all this, I'll draw an arc by center. So this is the center point. So radius of arc is 19 mm from this point to this point. So I'll remove the unwanted portions. These two are unwanted portions, and then select, say, return. So it says some part has not been connected. Connect those 2 points, say return. I'll select protrusion symmetric extent, and the thickness is 36 mm, say finish. So once you create this, we will create this cut section, that is of radius 43. So to do that, cut out, select this top plane, select arc by center. So this is the center point, and arc of radius 43. Start from this point, say return. So cut out, arrow pointing outwards, and for a distance of 41 mm, say finish. So after that, we have a rectangular cutout at the bottom for a depth of 2 mm at a distance of 8 mm on each side. So So 8 mm over here, 8 mm over here, and then to do that, select cutout, select bottom face, draw a rectangle like this. You can make it symmetric, so I will make it symmetric about horizontal axis. Now give the dimensions. From here to here it is 8 mm, and from here to here it is 8 mm, from here to here it is 8 mm. So after giving all the dimensions, say return, cut out for a depth of only 2 mm, say finish. So after that we have one more feature of square 20 mm for a depth of 7. So the center of that square is at a distance of 31. So solid part, cut out this bottom face. I will draw a square using rectangle toolbar. Make it collinear. This line is collinear with this line. This line is collinear with this line. And give the dimensions 20. So from this point to the center of that square is at a distance of 31 mm. Say return. It is for a depth of 7. Enter. Left click. Finish. And again cut out. Again this bottom face of the square. Draw a circle from the center. Give the dimensions of the circle as 10. And from the center to this center of the circle, it is at a distance of 31. Say return. Cut out throughout. That is for a distance you can give like this. So after that we have this round feature, so, and then this feature. So we will do round feature now. So select round command, select this edge, give the radius as 6, preview, and finish. So after that we have a cutout of profile like this. So this is square of 8 and radius of 5 mm, which is at a distance of 128. That is 128 divided by 2 is 64 mm. So cut out at the top plane. So I will draw a rectangle like this. So it is the distance of 8 mm, and then I'll make it symmetric about horizontal axis. This dimension is 10. So from the center to the center of the square, it is at a distance of 128 divided by 2, that is 64 mm. And now I'll take arc by center. So this is my center point. Start point of the arc is this one, and end point of the arc is this point. So same way, center of the arc, start point of this arc, and end point is this. So trim off the unwanted portions. These two are not required. So return, cut out throughout, and then say finish. So this is the feature that we have created now. So after creating all these features, we will mirror this feature. So select mirror copy, select this feature, select this right reference plane, and then say finish. So after doing this, we have diameter 6, hole of diameter 6 for a depth of 6 mm. So to create that, we will create a plane, or we will add up the distance. 12 plus 3, 15, plus 19 is 12 plus 3, 15 plus 19 is 34, plus 6 is 40 mm. So we will create a hole. So to do that, go for hole options. It is simple hole. Select finite extent. Give hole depth as 40 mm. V bottom. Diameter of the hole is 6. Say OK. So this is the plane. So place the hole at the center like this. Say return and say finish. So now our body part is complete. File, save as. Go for any drive. I have selected drive D. New folder, plumber block. OK. Volume F. Plumber block. Say OK. And here type the file name as body and save. So body has been created. The second part is cap. So again, to do cap, we will start from the center and draw the profile or right half section of the cap. Solid part, protrusion, front plane, line command, start from the center. Create a profile like this. Now give the dimensions. This is 12 mm. This is 10 mm. So from here to here it is 44 mm, and from the center to the end of this it is 43 mm. So 44 divided by 2, 22, and from center to the end of this it is 43. So after this we have an arc by center. So I'll select some point on this vertical line and draw an arc like this, and from the same center I'll draw one more arc like this. Now we will check the dimension of the arcs. So one arc is 19 mm and one is 36 mm at a distance of 6 mm. 19 and 36 at a distance of 6 mm. So first I will give the distance, smart dimension, from this to the center of the arc, from this point to the center, from this point it is 6 mm. And now we will give these two dimensions. This is 19 mm radius and this is 36 mm radius. And now trim off the unwanted portions. And then extend this line. Extend. say return. So protrusion symmetric extent for a thickness of 36, say finish. So next we will do this cutout of radius 43. Cutout, top plane, arc by center. This is the center point. Draw an arc like this. Give the dimension for the arc 43. Say return. Arrow pointing outwards and depth. You can give how much ever you want. So after that, we have this hole feature, that is two holes of diameter 10.5 at a distance of 31 mm from the center. Again cut out, top plane, take circle of diameter 10.5, and from the center to the center of the circle it is at a distance of 31. Cut out throughout, say finish. So after that we have one more cutout feature here with the same center of radius 12 mm. So again I will select cutout command, select this same face, circle with the same center of radius 12 mm, that is diameter 24. Say return. Cutout direction is upwards, and then say finish. So after creating all this, we have a counter bore hole at the center, and then our cap will be completed. So for that, first we will mirror copy this feature, select this right plane and say finish. Now we will create a hole. So to create a hole, select hole command, go for hole options. It is counter bore hole of diameter 3 mm. Counter bore diameter is 6 mm. Counter bore depth is 10 mm. And go for hole finite extent. Through next, sorry, we do not want hole bottom. Say OK. So we should create one parallel plane from this bottom plane to this top, a distance of 31, and place a hole here. Say return. Hole pointing downwards. Say finish. So this is the hole which we have created, which looks like this from the front view. And then our part cap is finished. Go for file, save as, save it as cap. Close this. So after creating part 2, next we will create bearing bottom half and then bearing top half. To create bearing bottom half, we will draw a profile which looks like this. So to create this, we will select solid part, revolved protrusion, front plane, line from the center like this. Close this. So now we will give the dimensions. So this is 25. From here to here it is 19. From here to here it is 17.5, and this distance is 7 mm. This distance is 7 mm. From here, from this point to this point it is 25 mm. And then draw a line like this anywhere on that profile. Give the dimensions from here to this dimension, it is at a distance of 12.5, and trim off the unwanted portions. So your profile should look like this. So after creating all this, select axis of revolution, select this horizontal axis, say return. So angle of revolution is 180 degree, and then say finish. So we have created half portion of the bearing bottom. Say mirror copy, select this feature, select this right plane, say finish. So in bearing bottom half we have a 5 mm protrusion like this. So to create that, we will select protrusion command, parallel plane from the bottom to this top, it is at a distance of 17.5 plus 5, it is 22.5. So create a plane at a distance of 22.5 from the bottom, and then draw a circle at the center like this. So diameter of the circle is 6 mm. Say return. So distance is 5 mm. So increase the distance by 1 mm, so that increase the distance by say 2 mm, so that everything appears nice and clean. So now bearing bottom half is ready. File, save as, bearing bottom half, save, close this. So next, in the same way, we will create bearing top half with the same dimension. The only difference is we have a hole at the center, solid part, evolved protrusion, front plane, line command from the center onto the right side, again onto the top, profile like this. Now give the dimensions. So this is 25, this is 19, this is 17.5, and this is 7 mm, this is again 7 mm, and from here to here it is 25 mm. And after giving all this dimension, draw a line anywhere here, go for smart dimension. From here to this line, it is at a distance of 12.5, and trim off the unwanted portions. Trim. So after trimming all this, select axis of revolution, horizontal axis, return. Angle of revolution is 180 degree, enter, left click, finish, come out of the command. So we will mirror this, mirror copy, select this feature, select the plane, finish, come out of the command. So we have hole at the center of diameter 4 like this. So we will create that hole using cutout command. So this is the front plane, circle at the center of diameter 4 mm, return, cutout throughout, and say finish. So file this, save this file as bearing top half. Close this. We will see the fifth part, that is bolt M10. So to create that, first we will create a square of 18 mm for a depth of or thickness of 6.5. Solid edge, solid part, protrusion, top plane, rectangle. So I'll make this symmetric first about vertical axis, and I'll make this symmetric about horizontal axis. Give the dimensioning, say 18 mm. So make all the sides equal. This line should be equal to this. And now say return. It is for a thickness of 6.5. Say finish. So after that, we have a revolved cutout. So select revolved cutout, select front plane, select line command, draw a line from this side at an angle of 30 degree. Select axis of revolution, this vertical axis, return. So arrow pointing downwards and give the revolution as 360 degree and then say finish. So your bolt head looks like this. So after that we will create the threaded portion, that is protrusion. Select this plane, draw a circle from the center of diameter 10 mm, return. So the distance is 75 mm and say finish. So now we have created the square head of 18 mm with this cutout and 75 mm length. So threaded portion is only 26. So we will create a thread of 26. So to do that, select thread command, say straight thread. It will ask the cylinder to thread. This is the cylinder to thread. Start point of the thread is this one. So select finite value, give it as 26, type is M10, then say finish. So go for file, save as, bolt, M10, save. Close this part. So next part or sixth part is nut. So of M10 of depth, thickness 8 mm. Go for solid edge, solid part, select protrusion, select top plane, draw a profile which looks like an hexagon. Like this. And now make every line equal. Select equal. This line should be equal to this should be equal to this should be equal to this. All make all the lines equal and now give the angle between this line and this line. It should be 120 degrees and now give the length of each, that is 10 mm. So after giving all this, make this hexagon to sit exactly at the center. So smart dimension from this point to the center of this line it should be 0, so that it comes and sits at the center. Say return. It is 8 mm depth or 8 mm thickness. Say finish. So after that we have revolved cutout. Select front plane, draw a line command, take line command, draw a line like this. Give the angle between this line and this line as 30 degree. Select axis of revolution, that is vertical axis. Return, arrow pointing downwards 360 degree and say finish. So after doing that revolved cutout, our nut looks like this. So same way we will create a revolved cutout at the top. Revolved cutout, front plane, line command. From this edge, line pointing downwards, angle between this line and this line, it is at a angle of 30 degree. Axis of revolution is vertical. Return, arrow pointing upwards, 360 degree is the axis revolution. Finish. So after giving all those things, select select hole, go for hole options. It is threaded hole of diameter 10. To hole extent, this is M10. Say OK. Place the hole at the center. Say return, whole direction is downwards. Say finish. File, save as nut M10. Save. Close this. Next we will see the seventh part, which is called as lock nut M10 of thickness 5 mm. So solid part, protrusion, top plane, line command, draw a profile which looks like an hexagon like this, make every line equal, and give the angle between lines 120 degree. Now give the dimension of each side, that is 10 mm. So after that, make this hexagon to sit at the center, horizontal line and center of that line. It should be at a distance of 0. Say return, thickness is 5 mm, and say finish. Now we will do revolved cutout. Revolved cutout, select front plane, line command from this edge, and then angle between this line and this line, it should be at a distance of 30. Sorry, it should be at an angle of 30. Axis of revolution is vertical axis. Return, arrow pointing downwards, angle of rotation is 360 degree. Revolved cutout, front plane, line command, start from center, angle between this line and this line 30 mm, 30 degree. Axis of revolution is vertical. Return, arrow pointing downwards 360 degree. Say finish. So same way we will do another revolved cutout at the top, front plane, line command, line pointing downwards, angle between this line and this line, it should be 30 degrees. Axis of revolution is vertical. Return, arrow pointing upwards, then 360 degree. So this is how our nut looks like before doing the threading. So hole, go for hole options, threaded hole of diameter 10, select thread as M10 to hole extent, and then say OK. Select the plane and place the hole at the center. Return, hole direction is downwards, and then say finish. Go for file, save as, lock nut, then save. So we have completed 7 parts. So this is the 8-part shaft of diameter 25. Go for solid part, protrusion, top plane, take a circle, smart dimension, diameter 25, return, length can be anything, I'll give it as 60 mm, finish, file, save as, shaft, save. I'll close this. So all the 8 parts have been created in this session. Thank you.